There's this. Hello, everyone. It's our third Content Evolution nuWorld call, and I'm delighted to have you with us. We're recording, so if you have any objections to being recorded, you can remain off camera, quiet, or you can drop off, whatever your choice is. But we're delighted to have you with us, and we welcome your questions and comments when we get to the Q&A section. Our guest speaker today is Doug Hohulin. Doug is in Kansas City, so it's an hour earlier. Thanks for being up early, ready to share, Doug. I've known Doug now for about a year. I have, a duty in a similar role hosting people-centered internet calls, for people around the world. And Doug is an active member of People-Centered Internet, co-founded by Vince Cerf and Malin Funk. So we're glad that you have the ability to share. He is, you should really unpack your background, but you were at Motorola for a long time, right?
Right, 22 years at Motorola, then our division got bought by Nokia, and I was with them for 11 years.
Yeah, so a lot of time in mobility. I was on kind of the other side of that during my career for a piece of it, working on other mobile devices, more notebooks, tablets before they took off, right? And a lot of other mobile technologies. So we could probably compare notes on that. So Doug is here to talk about the wireless infrastructure, 5G and what's beyond that. He is an advisor and a consultant to a number of other organizations. And I'm really interested in what you have to say in the other Gs, right, that are going to be, coming soon. And I would be delighted if I could just get 5G out here, all right, in the woods, because we're at a point where it's 5GE, all right, which is kind of a pseudo. I think that would have been 4G LTE before, right? So they've rebranded it, all right, and it's the same stuff. It's still not fast enough. So we're delighted to have you, Doug. The floor is yours, and everyone, if you want to ask questions, just put them into the chat session, and I'll be delighted to call on you. Willie, anything that you want to say before we get underway? Perspectives from Hong Kong.
No, I think this will be a very interesting topic. Obviously mobility and the networking, it's a fundamental for all the application running on top of it. So it will be a good topic to go into for everyone, right?
Outstanding.
Thank you.
Thank you. Glad everyone is here. Doug.
Well, thank you so much. Again, I'm going to be talking about 5G, 6G, and 10G, and the many Gs beyond, a vision for the 2020s and 2030s. I gave my first 6G presentation in 2020, and we're in this technology Cambrian change. And so, what I'm hoping that you get out of this presentation is, first of all, understanding a little bit of the differences of 5G, 6G, 10G, which is the cable guys, cable labs are talking about that, and the many Gs beyond, the generations of technology. What are some of the use cases, and then how will they impact you and the world? So when I gave my first presentation on 6G, on 5G, that was a public presentation in 2015. I started working at it. I was on the Sprint account team, working in business development strategy and part of the standards liaison at Motorola to Sprint. And so in 2015, I talked to the T sensor, trillion sensor group down in Florida. Actually, it's a place where they had robot surgery, the Da Vinci surgery, and I actually got to practice surgery. The surgery was successful. I removed funny bone, but it talked about these trillions of sensors, and there was hopes that sometime in the mid of this decade we'd get to a trillion sensors. We're not quite there. We're probably more in the over 100 billion sensors, but we still have a little ways to go. But it is coming. And there's the Chips and Science Act that came along that I think will help it as well. and actually some of the Sustainability Act, the IRA Act that came along on this technology. So this technology is coming. So every 10 years, there's a new generation of technologies that's been kind of developed. Kind of how I look at it is there's standards organizations, all the companies come together and say, what technology can we develop? When can we develop it? And it seems like every 10 years, there's kind of like a major change in technology, both in the mobile side of the world, which I work on, and then also on fixed access as well. And so there's these platforms, there's the applications, and then there's the unexpected applications. So like 4G, Facebook and YouTube, Uber was enabled because of 4G technology. So, people think of it in terms of the bandwidth, and is kind of one of the areas, also what spectrum frequencies that are being available to enable this technology. In the fixed access, you have POTS lines, analog lines, and you have fiber that is happening as well. And I'll talk a little bit more about that. But these are the G's that come along, and then the platform, of course, along with it in the 2020s, cloud, in the 2010s and 2020. Cloud is the big area. Right now, AI is going to be, the coupling of wireless communication with AI is going to be very interesting to follow as well. So this presentation, as soon as 5G was launched, in fact, here's an example of when each technology was launched. In 1982 was the first analog cell phone was launched. When I joined Motorola, there were 7 million subs in the world. Then 2G came along, and you got 64 kilobit data. By the end of the decade, end of the century, we had 480 million subs on the planet, and then came along with 3G. By the end of 2009, we got to about 4.6 billion subs. And then 4G, we basically have 8 billion human subs, and then starting to do the Internet of Things devices. For 5G, it just launched in 2018. It was looking at peak data speeds of 10 gigabits per second, but each user gets about 100 megabits of speed. Is kind of what it was designed for. So like you have a shared 10 gigabit pipe of the service area that you're looking at. So it can use spectrum up to 100 gigahertz of spectrum. You have tens of billions of devices, like the Internet of Things devices. They worked on battery life too. So when you put an Internet of Thing out, you don't have to worry about batteries for 10 years. 1 millisecond latency was another big area. There was kind of 3 areas of 5G that they were looking at, which is billions of things, the Internet of Things. The other one was massive, broadband speeds, so that you can get the higher data speeds, and then also ultra reliability, low latency solutions for robotics and autonomous vehicle use cases. So that launched, usually when you launch a technology, it takes 5 to 6 years to get it rolled out. And then after that, it gets, optimized for the next 5 years, and then you get ready for the next G. And so 6G, some of the, and I'll be talking about the detail, but you have hundreds of gigabits, 100 gigabit peak speed, so about a factor of 10. You use more spectrum, up to terahertz of spectrums. You can support trillions of devices, 20-year battery life, 0.1 millisecond latencies, and all kinds of use cases that I'll be talking about as well.
Doug, question on the previous chart, the back formation subs, does that mean subscribers?
Yes, subscribers. So either, that's why I said human subscribers, because you're shifting from having individual humans to now having, Internet of Things, like computer subs, you have a subscribers tied to, like an iPad, right? Or some kind of, your smartwatch, so you get more and more device, subscriptions to the internet, how many different individual IP addresses would be a good way to think about it.
Very good. Thank you.
So, in fact, I kind of joke that, I've given public presentations on 4G through now 6G in 2020. I'm planning on in 2028 to give 7G. I saw this one talk about what is 4G. Voice is mostly too cheap to meter. So if you think about it in, the 2010s, you got unlimited voice data plans, right? That you didn't talk as much as you want, right? Because we're not metering that. And 5G, most people are now starting to get to have unlimited data plans. So now data is too cheap to meter. So what is 6G? I think is going to be virtual travel, a lot of artificial intelligence. Is mostly too cheap to meter, and connecting the unconnected around the world. And I'll talk a little bit about that as well. And then 7G, right now people aren't even talking about 7G, but I'm thinking, well, its reality is mostly too cheap to meter and imagine by 2040. So we'll see what happens. I go by Surfer Doug because I like to wake surf, but I like to also surf the internet. So that's kind of my handle. So, why are we doing this? Why are we spending all this energy into doing this? And, it's all about the use cases. So, this is a simple chart that just kind of shows the bandwidth requirements of these use cases, like the Internet of Things needs anywhere from tens of kilobits per second to, megabits per second for Internet of Things. And then latency could be low, it could be 10-second latency. It doesn't matter if you're measuring a water meter, having 10-second latency or even an hour latency is not a big deal. Especially battery life is more important to that. And then as you go into more of the video, and like 70% of the internet right now is on video. And so more and more data speeds there, and some of the 4K and 360 videos, if you've seen some of that. And then eventually virtual reality will take these, hundreds of megabits to gigabit speeds for these applications. And then for low latency, system controls, autonomous vehicles, robotics, and so forth, needs to have these in the millisecond and even in the sub-millisecond latencies. And if you've ever been in virtual reality, to have a full immersive experience that's like reality, you need to be actually down under 20 milliseconds of latency. So that's going to be very important. So you need both high bandwidth as well as low latency. So Nokia, I just saw this article where they said that they anticipate that, this factor right now, about 40 gigabytes per month is kind of what's being used. And they anticipate, you can go from a factor of 9x. And then eventually with the use of digital twins and metaverse applications and industry applications, you can go as much, maybe 100 times more by 2030 is this technology, especially if you get more 4K, 360 videos, all this immersive technology. So, our industry is trying to prepare for all these use cases, and the data continues to grow and grow. And so that's kind of why we're doing this. So, this is a spider diagram of what is kind of the what as they're looking at all the different features. And usually what happens is there's a group of like maybe 3,000 individuals to get together and say, okay, what features and functionalities do we want to implement? And usually, like Nokia, we're doing patents development, and we come up with some great ideas, and then we bring those into the standards body because we want our ideas to be the ones that are chosen, so we get licensing. And Qualcomm does the same. So, like latency, trying to get that better and better. So in this case, down from 1 millisecond, which is 5G latency, down to 0.1 millisecond latency. Reliability is another area. Connectivity, again, so going from hundreds of billions of devices to support trillions of devices. Peak data rates going down to 10 peak gigabits per second to 1 terabits per second is kind of what some of this technology is doing. And then with experience, from the 100 megabit kind of experience, 500 megabits of 5G, it's like 10 gigabits of 6G technology. So you can think of this spider diagram as this is what's kind of the things that are trying to be optimized, and this data of experience as well. And then, are we doing this, and can this be deployed? And each if I did the spider diagram of 4G and 3G, you see this increasing functionality, by basically a factor of 10. So, in my earlier slide, I talked about that 10G factor, 10x factor of each G comes along. So that's what we need to have all this functionality and all these use cases that I'll be talking about. So I have this about 4 years ago or 5 years ago, I was reading a history book. My dad's a historian, and I came across, that in 1802, there was 1 billion humans on the planet, which I thought was kind of interesting because 200 years later, there was 1 billion cell phones on the planet. And, and I thought, well, what about all these other billion things? And so in 2005, there was 1 billion internet users, a billion internet devices, 2007, PCs, 1 billion in 2008, vehicles, there's 1 billion in 2010, smartphone users, 2011. So, in 2014, there were actually more mobile devices in the planet than humans on the planet. So, this is, we're selling right now smartphones somewhere between 1.2 and 1.6 smartphones. There's about 6.2 billion smartphone connections. People are using about 4 hours and 48 minutes on their smartphone. So I started thinking, okay, well, given that, what's going to be the future? And so like in 2022, this year, we're going to have 1 billion 5G users on the planet. And so, how about digital twins and the metaverse users? And I'm thinking somewhere around the 2027 timeframe, there'll be 1 billion people using this immersive technology regularly, like at least an hour a day. And there'll be telepresence. And then there's about 1.3 billion students on the planet. And so can we get 1 billion students using over 25 megabits per second? And then in 2030, 1 billion students will be telelearning at least 50% of the time. So anyway, these are some of the things I was looking at as a running list of my billions and billions. It will be interesting to see what takes place, especially given COVID and now with the war in Ukraine and around the other challenges of energy around the world. But as a technologist, it's like, how do we solve problems? And I think communications is one way we can help to solve the problems of our world. So as I said before, this chart is a couple years old, but I just put it down to say, a few years ago, we were expecting by 2023 to have 1 billion cell phone users. The last data I had was in 2021, we had 619 million users. And so this year it's expected to be a bit over 1 billion 5G connections in the planet. So that's the cellular side of the planet, these 8 billion humans, and then Internet of Things with the cellular side. Then we also have these, the Wi-Fi. So there's 16 billion Wi-Fi units out there right now. They're generating about 5 trillion. They will generate about $5 trillion by 2025, up from 3.3 trillion last year. And so, there's cumulative devices shipped to 37 billion. So all this connectivity out there. And so the Wi-Fi, and there's complement between Wi-Fi and cellular. When you're in the home, you use Wi-Fi. When you go out, you use your cellular plan. And how do you optimize for these together? So, there's the Wi-Fi side of this technology. Wi-Fi right now, if you have the modem that's more than 3 years old, you're using Wi-Fi 5, you'll have 200 millisecond latencies. Now coming out with Wi-Fi 6 and 6E. Qualcomm, they're just talking about deploying Wi-Fi 7, Intel as well. It will have peak speeds of 5.8 gigabits per second. It will have latencies under 2 milliseconds. It will have lower energy use as well. So this is the technology, and it will be commercially available by the end of this year. So you'll start seeing these Wi-Fi 6Es and Wi-Fi 7 devices coming out, but that will give additional functionality, especially needing the low latencies of immersive technology. So that's the wireless guys, the cellular industry. I'm also been, I've actually in the 90s, I actually was involved with Motorola in cellular. We were one of the major set-top boxes and got to be involved with a project with the Cox Cable, Comcast, and actually they own 60% of the Sprint business as well. And so they have a technology called DOCSIS, data over cable service infrastructure. So they came out with a 10 gigabit maximum capacity. And so since they had that, they said, okay, this is going to be to a single end user that we can get the speeds out there. So we're going to call this 10G. In fact, the joke was, well, so 5G, what's twice as much as 5G? Well, that's 10G. And so they're going to start rolling out this 10G technology that gets downlead speeds of 10 gigabits per second maximum, 6 gigabits, and the uplink speed. I mean, if you do a speed test, usually, like for me, 600 megabit data plan in the downstream, but in the upstream, I only get 20 or 30 megabits per second. So it's more asynchronous. And the question is, how do we do, with some of this immersive technology, which can be both ways, we need to have high bit bandwidth in both directions. So that's what this DOCSIS 4.0 is going to be. And, this 10G technology. And there's about 72 million subscribers, internet subscribers that use the cable side. you know, Comcast, Charter, then, you know, you have the AT&Ts, Verizons, and Google Fibers of the world as well. But they're all rolling out this high gigabit speed technology, and the cable industry uses, they have a cable labs working on this technology. So about 3 years ago, Cable Labs came out with this 10G challenge to support a new way of how we, with these applications, right? Because you have all this underlying technology, but, you know, how's it going to improve the way we live, work, learn, and play? And so they came out with this challenge that's judged by Mayo Clinic with the Learn, which is healthcare, excuse me, the Live, which is healthcare, you know, Work, which is Corning, Learn, which is Zoom, and Play, which is Intel, is going to be doing the judging. And this is increase, you know, the speed, you know, which is one thing, lower latency, again, that's critical, enhanced security, which is also very critical, because if you don't have security, you're not going to be using this technology. So it has the power to and capabilities to make the technology of the future. So they have this 10G challenge. I was part of 2 projects, one with the KC Digital Drive, the University of Kansas, doing nursing immersive technology. And I could talk a little bit about that and maybe question and answers. Also, this MetaView 10G challenge with the KU Cancer Doctor on the best breast cancer care everywhere. So we submitted those 2 projects. We'll learn actually next week in Philadelphia if we won the prize. And I'm going to be there doing demonstrations of this technology. Cable Labs actually did do the near future Ready to Learn. They did it in Learn, Live, Work, and Play. The Learn one was very good because they have this 10-year-old girl that talks around, you know, what will the schools of the future look like? And it's just really exciting about how these next generation explorers will use this technology, because we have a lot of problems in our world. And if we're going to solve it, we need the next generation to step up, be explorers, innovators, creativity, to use this technology. So this is a nice 3-minute video. You know, I can send out this slide deck if you want, and I'd highly recommend, if you want something inspirational, if you have kids or grandkids and want them to encourage on education, encourage you to watch this, you know, 3-minute video. Fantastic.
Yeah, we would like that deck. Thank you.
Yeah. You know, Xfinity rolling out this new gigabit, multi-gigabit speed services. You know, in the old days, you know, you have, you know, like the 75 and 5 megabit plans, you know, like I have the 600 megabit, but I only have 15 megabit uplink span. Like a nursing instructor, this program we're working with the KU School of Nursing, her Wi-Fi speeds downlink is only 43 megabits per second, uplink speeds 21 megabits per second. And so what we're trying to do is using this 10G technology, get her up to gigabit speeds, you know, so we'll come over here and, you know, we'll get her a gigabit speed and 200 megabits uplink. So that one of the problems with this, you say, well, you know, like some of the applications, maybe I can get by with, you know, 50 megabits, you know, 20, 30 megabits, but then you shared with all your family members in the house. And so all of a sudden, you know, you're only having, you know, 10 megabit speeds when you're being shared. And it's a really challenge for education, tele-education projects as well. So with, you know, Nokia, you know, 5G, this readiness report, where this technology is going, they estimate it will be $8 trillion in value around the world, enabled by AI, blockchain, AR, VR in the enterprise, smart cities, autonomous vehicles, virtual learning, remote healthcare. So this is, you know, if you go to this report, you can see all this opportunity and where this is going. Now, the thing is this is a slide that was looking at all the different reports out there. And as you can see, like here's the 5G, you know, what the economic value is. And right now we're just at the low point of this S curve. And so, you know, by, you know, 2025, you know, we may only be around $2 trillion of value. And the expectation, like, remember when I said, you know, it takes about 5 to 6 years to roll out this technology. You know, we'd love to have it, you know, day one, you turn it on and it just works everywhere, but that's not reality. You know, and also people have to get, you know, optimized for the devices, the applications, and so forth. But you know, Ericsson by 2026, I think they said 3.3 trillion. Nokia's around $8 trillion. Qualcomm issued a report and they're up at the 13 trillions by 2035. And, you know, looking at manufacturing, wholesale, retail, public service, and others is, you know, where they're going. So this is a slide from Qualcomm. They published it, I think in 2019 is where they came up with 13.2 trillion. In 27, it was 12.3 trillion. So they upped the numbers, and, you know, in different areas, you know, healthcare, I'm very interested in education, manufacturing, with the Chips and Science Act, as well as the, I think with more and more manufacturing, especially here to the United States, there's this huge opportunity to grow information and communications. So this is where 5G will help enable additional industry output. And you can see the different sectors that are coming along. The Alliance for Telecommunication Industry, which is a standards organization that here in the United States that feeds into the global industry for cellular infrastructure, looks at the application enablement of this technology, look at the devices that are going to be out there, like the 4K TVs, industrial robots, autonomous vehicles, domestic robots, and this technology out there, and then when the network's being developed for the deployment of that. And that's where, like here in 6G, they have it, about late 2020s and closer to 2030s. But this is the technologies coming out, and they track this and seeing where this is going and how to optimize, for the applications, devices, and the networks. So, they started launching 6G, talking about this in 2018, 2019. And at Nokia, this public slide was showing that, there's 6 technologies enablers for 6G. So artificial intelligence in the air interface, so more and more intelligence to optimize the air interface intelligence, new spectrum technologies going from 100 gigabits of spectrum utilization up to 3 terahertz of spectrum. So you have 10 times more spectrum that you can use for this deployment. Now there's a lot of challenges with deploying more and more spectrum, but how can I use this great spectrum, all the spectrum that's available? Like light is up at 700 nanometers. So this, 700 terahertz of spectrum. So you have all, how do you use the spectrum that's available to make it more optimizing for that? Then you have network as a sensor. So all these sensors, again, as you're going to tens of billions of sensors to hundreds of billions to trillions of sensors. How do you deploy a network and support that? Some of the core, the radio and the core, how you converge that and how do you specialize that for different use cases? Extreme connectivity, as I mentioned before, going up to terabits per second, and then security and trust, because that's absolutely critical. That you have to, we kind of an arms race against the bad guys, that they come up with ways to hack into our systems, and we have to come up with ways that make it more secure and trusted, especially with the end user, not being sophisticated. So how do we protect the end user when they may do things that it makes it more vulnerable for the system? So these are the 6 technologies that are being developed around 6G. The 6G edge intelligence. I'm not going to go through this slide in general, but the one thing this is a white paper that they have in the 6G channel.com, but they talk about there's a need for intelligent internet of intelligent things. And so how do you deploy that? How do you put artificial intelligence in the system so that you can meet some of the security and functionality aspects of what technology gets deployed, especially as you're deploying trillions of things into the network. So along with 5G and 6G, which with up to $15 trillion of economic value, AI is also supposed to be $15 trillion of economic value by 2030. So this is going to be really exciting as well, where it's going. So there's in Finland, they got together and they put together this program. It's called the 6G channel, looking at all these. They put these white papers out in 2020 saying, where do we see 6G going? What's the more important thing? So there's all these white papers. The ones that I find most interesting, one was about SDGs, and sustainability goals. How can we help with that? Connectivity for remote areas, which is sometimes connecting the unconnected, which I'm very passionate about. How do you integrate between Starlink and the cellular network? And if you've seen the announcement recently, T-Mobile announced that they're working with Starlink so that I can at least do texting on my phone to the Starlink network. Apple announced the same, that they can have texting on their cell phones as well. So at least you can have some connectivity anywhere on the planet. And, that's going to be an exciting time to help connect the unconnected. So these are areas that, I think it will be interesting to see what's going on in some of the AI areas. areas, and machine learning is also something that, you know, I think to follow as well, because there's a marriage between these two together. So, you know, I'm going to stop here for see if there's any questions on this first one. But, you know, at the end of the day, and this is where, you know, the people-centered internet is about, is like, how do we help sustainability goals that were developed by the UN? How is our cellular industry helping with those? The wireless industry helping with that? Are we on track? Unfortunately not. And actually last year and this year basically put us even back because of that. But I believe that wireless communication can really help with this. So we're tracking how can our technology help with these sustainability goals, and how can we make a better planet? So, you know, I know we're kind of at the 20-minute time frame. I just wondered if there were any questions now. If not, I can keep going for another 10 minutes and then we can have questions there. But any initial questions right now?
Yeah, let me just jump in on an earlier chart, and at the intersection of this chart, there was kind of another category of, yes, and here's how we're going to cover rural areas, right? And you know, that's always been kind of a set aside, you know, that's a different issue, right? You know, there's kind of steep drop off for connectivity or not being connected with these newer, you know, 5G, 6G, so on and so forth. So what do you see as the ability to serve those less urban markets?
Right. And like, what, about 6 or 7 years ago, the FCC started auctioning off spectrum. They took away, you know, that's when they changed over from analog television to digital television. They took some of that spectrum at the low frequency bands and auctioned that off for this. So like T-Mobile has a lot of low band frequencies. And so just like your television station, you know, you may get 100 miles out or 550 miles out a television station. So they're deploying 5G there. Now, again, you don't get, you know, 1 gigabit speeds like you do at a high frequency spectrum, but at least you get, you know, 50 megabit speeds to 100 megabit speeds at the lower, you know, with these low band frequencies. So, you know, that's the kind of the idea, is that they have a you know, kind of, they call it a wedding cake effect, you know, where you have this, you know, at least 50 megabits everywhere. And then you do, you know, 100 megabits and then up to gigabits, where you have, you know, these picocells that can give a very high data rates, you know, just like Wi-Fi, you know, you can get 5 gigabits per second in your house, right? If you have the, you know, a DOCSIS solution, DOCSIS 4.0 and Wi-Fi 6.0 or 7.0 technology. So bottom line is, you know, how do you optimize that? The challenges, the rural area is going to be an issue. The good news is, you know, the different acts that came out the last year and this year from the government. It did $65 billion to put broadband everywhere. You know, there was these RDOF auctions that you know, like you know, right now there's a debate in Starlink, can they be part of this or not? But like Starlink is trying to integrate, like I said, you know, some of the cellular with the Starlink technology, so you can get at least 100 megabits everywhere. So this is the technology being rolled out. It's again, it'll take time, but I think by 2030, in fact, I have a few slides I can show. I'm connecting the unconnected, and that's the goal. Is not only here in the United States, you know, how do I get in rural Kansas this connectivity, but in rural Africa, which you know, this is the challenge.
Yeah. So we also have one other question, and then we'll go back to the flow of your presentation. Jim Sporer is asking, how many more entities, people, devices, digital twins with higher G connections will change service systems engineering as a discipline? Jim, you want to add anything to that question?
Sure. The reason I'm asking the question, and thanks for this great presentation, very insightful, learning a lot, is the National Academy of Engineering. I'm working with them to run a online event on October 17th, where we're looking at that question. And I thought I would try to get some of your insights. I just put together really quickly a survey. If anybody else has insights on this question, it probably takes 5 minutes to do it. It's a real short one. But yeah, if you could maybe share, Doug, just a little bit of your thinking about people who are building systems in the future, you know, what kind of changes to the discipline do you imagine will happen?
Yeah, actually, and I won't show it on this because I have to dig down. I have like 150 charts, but I will, if I'll send out this deck and I'll include that in the upper part of this. And it says, I think it's about 2 million new jobs for 5G being rolled out in this decade, and where each country is as well. So there's a report that Qualcomm commissioned. So it's not only about, the, $15 trillion business, or $13 trillion of business opportunity, but there's 2 million job opportunity as well. And then factory automation. So as more and more things get efficient, there's new job opportunities. I think like here in Kansas, Kansas City, we're doing a Panasonic EV plant, battery EV plant that's being developed. There's other ones around the country. So you're going to see more and more manufacturing happening here in the United States. So there's a coupling of, at these digital twins for manufacturing, you have communication for manufacturing, you have robotics for manufacturing, artificial intelligence. I think there's going to be a huge amount of job opportunities. The challenge will be is how do you do the training? And if you followed what's going on in the Inflation Reduction Act, which really I wish they would have called it Energy Sustainability on Climate and Job Training Act, because I think that's there's $360 billion of that funding around that area. In fact, if you're interested, I got a lot of material on that topic. But that is where, how do you not only implement this technology, but how do you give good paying jobs and do the training for these people? When you're deploying these wind turbines, right now there's like 78,000 wind turbines in the database registered here in the United States. How do you train for that? How do you get people to train? And that's where I think a digital twin, first practice training on a wind turbine, virtually first, so you know how to do everything before you go into the physical world and do the actual job. So I think these are the areas that this technology will help, both with the metaverse, VR technology, and also communication technology. So
that's great. So let's do 5 more minutes of presentation, then we're going to go to full Q&A, okay?
Okay, sounds good. Yeah, so just wanted to highlight, this is about a 3-year-old chart, but I really liked it. It's about remote and rural connectivity. How do you connect the unconnected? This is just with 4G technology in 2019. But as you can see, Africa and most Asia is just really dark in terms of connectivity, and they're using 2G, old 1990 technology, and think of the economic, how many challenges they have because of this limitations. Like if you had to use technology of 30 years ago, how inefficient you would be in your technology. So satellite technology is being developed. China's talking about a 500 times more capacity, and it's going to cost about $10 billion to put that in, to give 2 gigabits per data speeds. Starlink, of course, is putting this together. This is a 2019 slide of capacity, but that's something I'm very passionate about, connecting the unconnected. I would just say, I'm also very passionate about sustainability. Right now, our industry uses about 2 billion tons of CO2 gas emissions, but by using that, just like this call right now, we're avoiding traveling in person. So by enabling this technology, we can reduce greenhouse gas emissions by a factor of 10. So that's something that we're looking at as well. Like for instance, Nokia and Ericsson as well, all the industries are saying we're committed to reducing our greenhouse gases by a factor of 5, but at the same time growing our data, supporting 20 times more data speeds at the same time. So this is what's being done. Also using, creating these technologies for 7 trillion wireless devices for the over 7, connecting everyone, connecting the unconnected for this technology. SoftBank has this slide I liked. It's about, there's expectation is that you'll go to 1,000 devices per person. So how can we have a sustainable world with all this technology? So this is going to be our challenge of these next 20 years to look at. So again, the Inflation Reduction Act around energy and climate, Paris Agreement is getting 50% below the 2005 targets, and, if you notice here, we actually have gone up since 2020, and so, how can we change this? And this is going to be our challenge. So, I believe that metaverse technologies, digital twin technologies is the way to, one way to help solve the climate, and reduce our greenhouse gas emissions. So, if we grow the physical economy by 2x, we're going to grow our greenhouse gas emissions. Maybe we can be a little bit more efficient, but we're going to still grow, and we can't keep growing. But if we can grow the metaverse, this digital economy by a factor of 10, we can grow the physical, we can reduce the physical economy and reduce emissions and have abundance for all. So that's where I'm, my focus is around is how to use this technology to reduce our carbon footprint. There's going to be 20 trillion objects by 2040. Are they going to be physical, virtual? How to minimize our carbon footprint? So like this conference right now, if two people in a Zoom meeting generates, like 3 grams of carbon dioxide, right? And that's equivalent of driving like 52 feet in a car, right? Like I'm going to go to a conference next week, and it's estimated it's going to take me, I'm going to use up 1 ton of CO2 gas emissions per person. And I used to travel like to 5 or 6 conferences, probably did a trip at least once a month. Right. And so in the United States, the average person uses 13 tons of carbon dioxide a year. So one business trip, it takes 1 ton, right? So in India, it's only it's 1 ton of CO2 emissions as well. So I don't see any way to solve greenhouse gas emissions if we're not reducing our traveling. And so that's something I'm very passionate about. I would just say, since I want to stop in the next 5 minutes, is that the internet, the metaverse. I have a friend, she who's a laser safety officer nurse. And when we talk about the metaverse, she says, well, that sounds like a ride found at Disney World, which I actually liked, because it's like Disney World has these immersive experiences, these wonder and imaginations. And so Alvin Grayland, the president of HTC China, says the metaverse is internet plus the spatial, the 3D, plus these devices, virtual reality. And so I added, so we have communication, the 5Gs, 10Gs, 6Gs, Wi-Fi, cloud, AI, digital twins, digital wallets, NFTs, avatars, blockchain. So all this technology is coming about. This kind of like this perfect storm of this technology that's going to be developed. So, I would say that, right now, you're wearing a pound headset that's kind of clunky, but in the future, you're going to have these smart glasses. Right now, they have a wired, but Qualcomm is estimating in the next 5 to 10 years, you're going to just have smart glasses. David Rose of MIT Media Lab talks about super sight. That will have the super sight integrated with artificial intelligence, cloud information that does amazing things. So I recommend that book as well. So, I just, to end this talk, the summary that the 2020s will be a climate of change. It's climate change, it's COVID, it's technology change, there's communication, biology, energy, transportation. So many governments, universities, and companies are trying to plan for 6G and 5G is deployed. Like I said, there's this Chips and Science Act, which includes communication technology funding. 6G use cases and 5G as well aligns with the UN's sustainability goals. 6G use cases can connect the unconnected. And so that's the goal, is not just to make it to the rich countries here in the United States, but we can connect everyone around the world and give them this abundance as well. 6G use cases can drive sustainability, profitable business into the 2020s. Again, this climate emergency that we have, can we have virtual presence so we're not traveling as much? And we do more meaningful things, so we can use that time to connect with the people physically that we love at our homes. And you can still connect virtually to the people you love, but you don't have to travel if you don't need to. And then, can we achieve this abundance where sustainable energy, information, communication, virtual travel is too cheap to meter? So in Kansas, the Kansas seal is ad astra per aspera, which is to the scars through difficulty. I would add or technology, because technology makes going to the stars so much easier. So I add Starlink's, SpaceX's Starship in our chart. We have a lot of difficulty deploying this technology, difficulties in our history, but I believe, we can have this technology that can make us go into the stars. So with that, I'm open to more questions, and thank you for your time.
Thanks, Doug. Appreciate it. Does Kansas have any launch bases for Ascent right now? I think there are 14 of those in the United States. All right. You have a spaceport yet?
I don't think we do. I need to look that up.
You got a lot of flat land for it. All right. Yeah, it'd be a good thing to have.
We're number 2 in wind power, just because Kansas people of the South wind.
There you go.
On energy, the past, present, and future of energy.
Yeah.
And I'm very proud to be from Kansas and this wind energy, and hence why you're doing a lot of manufacturing in Texas and Oklahoma, Kansas, is because we have low cost energy, because we're a windy state.
Yeah, it's great. And I want to just say before we call on our next person with questions, which is Willie Yam and then Lynn Wells, is that I checked my phone since the time you started, and I do have full 5G service now. So that's happened in the last week. All right. So thank you for prompting me to look. All right.
Well, what's your speed test? I would be interested.
I'll let you know before we conclude. Yeah. Let's go to Willie Yam. Willie, you had some questions about the difference and the opportunities between public 5G and private 5G, such as 5G in manufacturing and closed spaces. Willie?
Oh yeah. Sorry, I've been cut off for a few seconds. Did you ask the question on behalf of me?
Yeah, but you can amplify. It's public versus private 5G.
Exactly. My experience previously dealing with a 5G solutions was for some of the enterprise to adopt 5G on their own private network. The reason, obviously, it's more security and more control over how do they, in terms of deploying 5G for their enterprise applications, such as, industrial IoT and smart manufacturing, and for obviously extending to robotics and so on and so forth, right? I was wondering whether do you have any? Can you shed some light on some of the development, particularly Open RAN area architecture that's being adopted in the enterprise space?
Sure. Yeah. So there's in fact, I might throw that slide into this deck, but there's 10 million enterprises around the world, locations, and as you said, factories and manufacturing warehouses and so forth. And so, about 5 years ago, and actually I worked on this project on enterprise 5G, just like, a lot of companies have Wi-Fi in their facilities as well. But now with 5G, the US government and other governments have introduced bands so that people can have 5G by their spectrum. So that it's called the CBRS band, and they did auctions of it, and it's a shared service. So like if you're, you can have you can buy the license, but if you're not using it, someone else can actually use that spectrum. So it's a way that
right.
Of spectrum up in the 3 gigahertz band, excuse me, and that's opening up a lot of schools actually are starting to deploy private 5G networks, just like schools had Wi-Fi networks. They're adding 5G private networks as well. And you mentioned Open RAN. That's another deployment. So how do you lower the cost of this 5G equipment, because Wi-Fi is so much cheaper because it's an open standard.
Right.
So that's why they did Open RAN in 5G. Now the challenge with Open RAN is then, you say, okay, I have this open technology, but if things don't work, who do I blame, right? And that's the value of, going to a Nokia or Ericsson or so forth, because then, they can do a complete solution, but you still have a private network. And even the cellular operators, they have private, they can deploy a private network, and they can say, okay, in the school, we'll set up, this is where it's dedicated to you. Like FirstNet is a great example of private network. FirstNet, they spent $8 billion doing a private network. Now AT&T is actually doing the deployment of that and the build out and the operation of that. But that is a private network for the first responders, the police and fire. And so that is a technology that's optimized specifically for first responders. So that the good news is there's spectrum, there's technology that's optimized for these private networks. There's need, 10 million enterprise spaces. And like I said, I'll throw in a slide about that just so you can see that opportunity as well. Yeah. That goes back to this jobs as well, so that as you're deploying in these 10 million different locations, you need, technologists and IT people that can operate and maintain it. I mean, one of the challenges of life in general is not only, there's CapEx, like if you buy a house, deploying the house, or you buy a car, it's great. I got this car and now I have to operate it, and so my rule of thumb is 10% the cost of what you ever buy. Like let's say it's $50,000 for a car. You expect about $10,000 of operation costs, at least $5,000 of operation costs to keep it running. And so you have to remember OpEx and CapEx. And so these are the challenges as private networks, is how do you, not only how do you implement it, but then keep it running over the next 5 to 10 years.
Okay.
Right.
Next question is from Lynn Wells. Lynn?
Yeah. So the question, you'd mentioned one of your slides, a post-IP new internet in the early 2030s. What does that look like?
Well, so actually, when I flip it the other way, I'm saying the metaverse is really whatever the internet is in 2030, right? And so there's going to be, like the internet 2.0, they're looking at, kind of a brand new replacement. And I'm not an expert in internet 2.0. I kind of followed at a high level. But like 6G, technology, you have devices, all these new devices that are coming out. In fact, I have a slide on that. I might throw that up into the top of this deck that looks at all these different devices that plug into for the internet. So whatever we, the internet of the 2010s or, the 1990s, 2000s, 2010s, every 10 years, it seems like there's a new amazing opportunities of the internet. In fact, Mary Meeker, I'll just throw it in there, but she has, what is the internet every decade, just like what is,
Have you seen Bill Coleman's 10-year cycles, 30-year cycles with 10-year phases on the history of the internet since 1970?
Well, actually, the slide I have is shows the 30-year cycle of one dimension, like the mainframes,
Yeah, with this basically says that his cycles are innovation boom or bust, followed by consolidation, followed by commoditization.
Okay, no, I haven't seen that.
It's really interesting. It starts off with semiconductors, which
Okay.
go through the cycle, and that then becomes the basis for the personal computer, which becomes the basis for the edge of the initial internet, which becomes the basis for. It's really interesting.
Yeah, be interested. I'll look it up on the 30-year cycle.
Thanks, Lynn. Thanks for that question. The internet continues to evolve for sure. We have questions from Bill Sung. Bill?
Yeah, thanks for this presentation, Doug. It's been really, really informative. A couple of questions for me. I put it in the sidebar too. First off, I love that chart you had up front where, as you went through each new generation of tech, there was acknowledgement of kind of the new unanticipated use cases. Has anybody ever done a level of analysis to try to understand, okay, how much new traffic came about from the unexpected application versus kind of just the existing applications scaled up? Just kind of curious, like what kind of acceleration happens with these unexpected applications here?
Yeah, I know McKinsey, in fact, when cellular first came out in the 80s, the question when the Bell companies, was breaking up, do you give it to the, to the Bell companies, which they did, versus give it to the AT&Ts, the long distance companies. And the reason was they only anticipated a couple million cellular users, so they way undershot that. Now, Internet of Things, they were expecting to have, 50 billion Internet of Things by 2020. And I think right now we're on track by 2025 to have, 25 billion things. Still a big number, but, didn't reach the number, the expectation. McKinsey, I think, was talking about $4 trillion of Internet of Things. And so the number is a lot lower. So, consultants, they sometimes they underestimate, sometimes they overestimate, but that's the holy grail is looking for, what wasn't expected, right? Facebook, if you would have invested in Facebook or YouTube, Uber at the beginning, that's when you would have made a lot of money, right? And, the technology coming out in the short term, That's why people are spending, $100 billion a year in immersive technology right now, because they think that the spatial, this 3D technology is going to be the way to go. So we'll see where that goes. But yeah, I've seen something that, like, okay, we predicted, X, and, we were way under, or we were way over. The one statistic I do know is like 70% of the internet right now is videos, and 40% is cat videos. And also 40% is or animal videos. I thought that was an interesting statistic. The other is bots. I think 40% of the internet is bots talking to each other, right? Telling you to trying to make you angry and keep you on the system. So that's another problem we have in our network. But social media is a huge area. Half the 2.5 hours a day people spend on social media.
Yeah, I could ask all sorts of questions, because all that's sitting in the back of my mind is, of course, these providers have to pay for all this infrastructure somehow, or get somebody to pay for all this infrastructure. And, knowing kind of where these applications are coming from and then how they're going to be monetized is going to be where the payback comes, obviously, in the infrastructure. So that's always, very curious to me, is whether anybody's really kind of done that kind of analysis.
Yeah, well, and I think that's where this chart, I think, is from Qualcomm, and I have my links, so you can click on the links to get to different reports. But this is where they're expecting, by the the 2020 35 timeframe. And so we'll see. Is this going to did we underestimate? Did we overestimate? Here's the different industries. And what's going to change, right, of this technology, and then what's the thing? That's why I like this slide. These are the emerging technologies, but what things haven't we thought of that are going to be big, right? And is brain-computer interface? Personally, I think this brain-computer interface is like I want passive brain-computer interfaces I'm okay with, but invasive brain-computer interface, I'll let someone else do that for at least 10 years before I think about it. So.
Very good. And I might add, on your, technology progression chart, you might want to talk to Bill offline, because he was involved with Simon, which was one of, if not the first smartphone, but it was IBM smartphone. So you might want to prepare notes sometime. That was a interesting early transition point that didn't have a ramp any more than some of the Xerox PARC technology didn't have a ramp for Xerox, but it sure helped everybody else.
Yeah. Well,
all right, so
my one comment, I've been working on autonomous vehicles and on the 5G Automobile Association. There's 136 companies that are part of this, all the automobile industry. Like right now there's 1.3 billion or 1.2 billion vehicles on the planet. I think automated vehicle and communication technology, especially with EVs, you have EVs, AVs, shared vehicles, all this coming together is going to be very interesting. So if I had to bet on where there's going to be a lot of revenue coming from, I'd say it's around automated vehicle technology.
Yeah, I was going to quick comment on that, Doug. I was at an investor conference a few weeks back, and there's a comment. We're at this transition point where you're talking about sustainability. We have, I don't know how many billion vehicles on the planet. You probably had it on your chart, but all those internal combustion engine vehicles have to get replaced, and they're going to be replaced by ultimately probably some level of smart connected electric vehicle. So there's a whole set of technologies, industries, services that all revolve around that. So that's a huge economic driver. I don't know how much time we have, Kevin, but I'd be curious if I could ask my second question here.
I just want to say we're going to go into overtime for those of you who have joined us. We are grateful for you spending an hour of your day this month with us. We have some other great speakers queued up, right, for closing out the year. So thanks very much for being with us. We thank Doug, all right, for joining us today. It was very informative. It was faster than one chart per minute. All right, that's like a new, that's a standard, charts per minute. All right, of delivery. We'll take Bill's question, and then we'll take Mac Turner's question as we go into our overtime. For those of you who have to depart, we thank you again for being with us. Bill, your second question.
The second question, Doug, was, I don't know if you have any comment you want to make about potentially being a little bit more pessimistic here of like what kind of inhibitors or opportunities are there as kind of the global internet fractures, you know, with China walling off their internet, you know, you see probably the same thing happening in Russia and so forth. And then, you know, related to that is potential tensions and geopolitical tensions causing various countries or regions not wanting to adopt others' technologies. So, you know, obviously Huawei, ZTE are big infrastructure providers, but potentially not potentially be not wanting to adopt that technology because it's Chinese or whatever. So any potential comment on some of those effects and how that tilts some of these projections here?
So is it Elizabeth Economy? She has a book talking about China and technology. Of course, the Great Firewall, that, you know, where there's two internets, right? The Chinese internet and then the US. You know, over the last, you know, Huawei was the #1 cellular manufacturer. And then, you know, over the last 4 or 5 years, there was no Huawei equipment here in the United States and Europe as well. So, you know, there is this tendency of this, you know, the vision of technology. So it will be interesting to see where that goes. You know, that's one of the headwinds, though you have these Open RAN, which is like trying to make it so it's, you know, going from, you know, where you have this firewall to where you have an open system where everyone can share. So there's positives and negatives. You know, I think there's going to be a lot of headwinds in the 2020s, you know, of energy, especially food, you know, and so I would say, you know, how can, you know, look at my industry, where's my expertise? Can I help move the needle and make a difference? And that's where, you know, I look at, you know, what we can do with sustainability, right? You know, like, you know, can we lower our greenhouse gas footprint so that, you know, people can have energy for food and heating and so forth, right? You know, so people fly less and communicate more. So that's where, you know, this has been my message, is that, hey, tell the presidents to reduce CO2 gas emissions. And so I'd say the greenest and safest kilometer mile you can travel is by traveling virtually. And the greenest car you can buy is the one you don't buy, right? And you don't use. So how can we do that? And so I think this chart, you know, is the one that if you're concerned about climate and greenhouse gas emissions, this is an important one. And so that's kind of where I've been looking, and especially now with these new you know, acts that came through Congress, how can we use some of this funding to lower our carbon footprint and minimize our greenhouse gas emissions?
Thank you. And our next question is from Mac Turner. Mac.
Thank you, Kevin. And Doug, thank you. And I will admit straight up that I do not have a voice in this space. However, I am really interested in circling back to where Kevin's question on the haves and the have-nots and the impact of the technology on culture. You know, we've looked at the material relative to the adoption within industries, but and I'm looking forward to seeing the video on education. However, I saw some numbers just yesterday, I think, that said during the time of COVID lockdown in which education was executed through technology, low and moderate income families trying to educate their children through that technology have experienced a 22-month loss in the quality of education. And knowing that culture evolves more rapidly within situations where one group has something and another group does not, what are your thoughts on the evolution of culture within the communities that have access to this evolving technology versus the communities that don't? And is there a potential paradox in which cultures that don't have this technology will need to physically move to places it's available, thus driving up greenhouse emissions and other types of issues that we're trying to prevent? Excuse the long and convoluted question, but I think it's a rather deep topic that needs to be unwrapped.
Yeah, so I guess a couple comments. That's why that slide on the billions and billions, like when do we get a billion? Because you get to a billion cell phones in 2002, and then in 2014 there's more cell phones in the planet than people. And yes, some people have 2 or 3 cell phones, and other people have none. But actually, there's 5 billion people that have a cell phone. Right now. So, and they're, like they have this programs, 1 laptop per child, so this technology there is a trickle down effect to this technology. It gets cheaper and cheaper. The first cell phone cost $1 million. The 5 billion cell phone costs $100. So that's something to think about. That's where, this they call it next generation NTNs, non-terrestrial networks like Starlink. And there's other satellite systems out there too, so I just don't want to target Starlink. But so how do you get, like in sub-Saharan Africa, in 2020, there was 45% of people in Africa were still using 2G technology, 100 kilobits of data. Think of how inefficient you would be in your company and your business or in your education, right? So there's 1.3 billion students in the world. How many of them, 2/3, according to the UN, don't have access to internet at home? And so how can we do that? I mean, that's where I think Starlink and other things could help. Realizing Starlink is expensive, but what you could do is have one hub of Starlink, and then you have a local network, Wi-Fi network, so that you can share that 100 megabit pipe with the students in the area or the schools and so forth, libraries and so forth. So there are ways, realizing that the rich, I have 3 or 4 devices, while people in Africa don't have as many. And the question is, how can I help give abundance to everyone? So those are things I'm looking at. And you raised a great point about COVID. I think I saw 200 million girls didn't have access to education. A good friend of mine, she's a computer teacher, and she's, I was asking her on a scale of 1 to 10, how engaged were these students on Zoom versus in the classroom. She has a fun class, it's computers. And she said that, on average, she thinks the kids are about 7 out of 10 engaged. And with Zoom, it went down to 5 or 6 out of 10. That you just don't engage the students unless, you're passionate about lifelong learning. I have another presentation where I talk about lifelong learning. Esther Wojcik has a book out, How to Raise Remarkable Children. One of her daughters is Susan, who's from CEO of YouTube, and one on Anne, which is on 23andMe. And so I recommend that book. But she talks about how to have more creativity, more wonder in the world. That's where I'm real excited about being part of this 10G challenge, and highly encouraged that people look at this near future, ready to learn, because this talks about what the future of schools could be, and not only in the rich, but these devices like Quest 2 costs $300, not $400. But this is ability, and actually I'm part of this program that we're putting 500 students into VR. These meta universities at the university level, and then at the grade school level. I have a friend, she's a VR lady. She's put 30,000 students in VR, and they're like, oh, the VR lady's here, and this immersive, creative, and all this is experience. So if you're interested, reach out to me. And I'm happy to talk about education, because I'm very passionate. My dad was an educator, history teacher. I have lots of teacher friends. I'm now actually an adjunct faculty member at the KU School of Nursing, looking at how do we make teaching or learning more fun, more creative, more entertaining. So kids want to be lifelong learners. So how do you go from being on a Zoom call where they're completely bored to where they're 10 out of 10? It's like, how can I get more content? How can I, look at, I go to the moon and I do these experiments. I get the most creative things. How do I be more creative? How do I be more entrepreneurships and so forth? So I'm going to be giving a podcast. Actually, the Cable Labs CEO has a podcast called Killer Innovation. And so I say that the ultimate killer innovation is having an education system that creates killer innovators. They create these innovations that just create killer applications that solve problems, and we need these students doing that. And so that's what, I can't, encourage everyone here, especially if you're over 50, to be a mentor to kids, students and 20-year-olds on innovation and how to encourage them to solve the world's problems. Because by the time we're 70, we need these innovators solving problems, or we're going to have trouble.
Thanks, Doug. And we're going to have our last question for this session from Mike Wing. Mike?
Yeah, it's not really a question. I just, it's everything in this is interesting that you've talked about, and among the things that are very interesting are the sort of historical extrapolation, historical models. And I just wonder if you're familiar with the model of Carlotta Perez about technology evolution. If not, I put a link in the chat for a Wikipedia article and an entry on it. It's an interesting model of how kind of game-changing general purpose technologies evolve and their relation to capital and stuff. So it's just a suggestion.
Okay, yeah, no, really appreciate it. I'm going to go through the chat and happy to look at all the posts that people put in. Yeah, and I'm open to any conversations. So, if you want to have a 30-minute conversation on the topics I bring out and expand on them, I'm happy to do that.
Fantastic. Thanks for offering that, Mike. You continue to crowd my library with new volumes, right? So it's a good thing. Doug, thanks so much for being with us. It was a vibrant hour and 15 minutes or so, and we're delighted that you could spend time with us. Anyone who wants to get in touch with Doug, let me know. Doug, if you want to put contact information to chat, you're welcome to do that at your discretion. And thank you for sharing your charts with us. You can also put contact information in the title slide, and that will allow people, when I distribute it, to reach out.
Okay. Yeah, I'm putting my contact information already.
Fantastic.
But looking forward to that.
Yeah, it's really, really fantastic to have you. Willie Yam.
Yes,
anything that you want to report from Hong Kong, from Greater Asia, in terms of news and views before we conclude today?
No, I mean, it's been a wonderful journey so far, for me at least. But this is definitely a very interesting and great topic, because it's the networking as well as the communication infrastructure builds everything for our new world. So this is the foundation, and I'm glad that Doug covers it very well. Thank you.
Yeah, it's very knowledgeable, and it shows. Doug, thanks again for being with us. Thanks everyone for joining this edition of Content Evolution's New World. Talk again soon. Cheers.
Thank you. Bye.
Bye.
Bye.